Hello everyone, welcome back to my YouTube channel. Today we are going to solve another coding challenge, which is very popular in interviews these days, which is longest increasing subsequence. And uh, as you can see in the screen, this is the question that we are going to solve. So let's straight dive in. In this question, we are given an array and we have to return the length of the longest increasing subsequence. So as given in this example, we have given an array 9142337, and the longest increasing subsequence would be 1237, which is of length 4. So there are actually two methods of solving this question. One method is using dynamic programming, and that for that method, the time complexity of that approach is O of n square. So we will first discuss that approach. Then there is another uh, good approach which can be solved in O of n log n using binary search. So we will discuss both of these one by one. Let's discuss the dynamic programming approach first. So dynamic approach is pretty much straightforward, I would say, because in that you basically create a dynamic array, and then you just stores the length. We iterate through each of the uh, points in the array, and we just increase the length of the dynamic uh, array by one if we are getting a number which is more than the previous one. So this is the code for that. So this is pretty much simple. So first of all, we initialize the dynamic array, which is dp, uh, dp of length of similar to the size of the array, and then we initialize the maximum value as 0 initially, and we will keep increasing that maximum value as we get the maximum length of the increasing array. So what we did, we first initialized that the array to 1. The reason behind this is basically the length of the maximum increasing array is going to be 1. Even if we have a complete decreasing array, then one number basically represent the length of that array, of that element basically. So for that, we are going to use two for loops. So in the first for loop, we are going to iterate it from 0 to the maximum length of the element of the array. And then we are going to initialize one more for loop, which is going to go from which is going to iterate from I to maximum length of the array. So the purpose is basically we are comparing two elements, and if the next element is bigger than the previous element, then we are increasing the dp value from 1. So this is the implementation of that. dpj is equals to dp maximum j plus comma dpi plus 1, and we are keep updating the maximum count iterator, the maximum count variable, if we get any maximum value in the dpl array, and then we simply return the maximum value of the maximum value that we are getting. Let's run that, and all of the test cases pass. So I'm not going to discuss this approach in much detail because this is pretty much straightforward, and I guess everybody would be very much familiar with this. So let's talk about the more efficient approach which can be solved in of n log n. So this can be deleted. Now that approach is good. The approach that we are going to talk about, in that approach, we are going to solve using O of n log n time complexity, in which we are going to iterate only using only one for loop uh, from 0 to n, and then we are going to find out the maximum the lower bound value using binary search algorithm with n log n for each iterator. So here is the implementation. So in the binary search, we are going to initialize a vector answer. That so basically this vector is going to take the so this vector of answer is basically going to take the values from the array. So what we are going to do first is first of all we are going to initialize a for loop which we are going to iterate from I equal to 0 to n, and then for each iterator we are going to find the lower bound of the uh, lower bound function here basically finds out the first element that is not less than the current value that we are going to insert into the answer. So basically it finds the first index in answer where nums I can be inserted without breaking the increasing order. So this is the purpose of the now. What we are going to do, we are going to use an if statement, which is like this. So if we reach the end of the answer vector, then we are going to directly push that element into the answer vector. Otherwise, we are going to replace that element with the lowest number that we are going to get now. So I know a lot of things might not be clear, but let's discuss it in more detail through an example. So this is the example. So in this, we have taken this input 10, 22, 9, 33, 21, 50, 41, 60. So in this, we have to find out the longest increasing subsequence. So basically, this answer vector that we initialize, this is not containing the longest increasing subsequence, but we are using a tricky way to find out the length of the longest increasing subsequence. So what it does, first of all, it takes the array, the element of the array 10, and then if it finds out an array element which is greater than all of the elements inside the array, then it directly push that element inside the array. So 22 is directly going to insert inside the array. Now when 9 comes, then it finds out which element is the first element which is greater than the element 9 here. So the first element 9 is the value 10 is greater than 9. So basically it replaces the value 9 from 10. And this is the new array. Now when 33 comes, the 33 value is more than all of the element currently present in the array. So it directly pushed into inside the array at the end. Now when 21 comes, now this lower bound function is basically finding out the first element that is not less than like the current value. So it finds the first index where it can be inserted without breaking the increasing order. So 9, this 22 is going to replace by 21. Similarly, when 50 is going to come, 50 is the maximum value, so it's going to get pushed at the end. Then 41 is going to come, and 41 is going to get replaced. 50 is going to get replaced by 41. And then at the end 60 comes. So basically, this final answer vector array does not represent the longest increasing subsequence, but it is the length of the answer vector is basically finding out the maximum length of the increasing subsequence. Uh, Here you are keeping answer as a placeholder for the smallest possible uh, last element of an increasing subsequence of a given length. This helps you maintain the potential for longer increasing subsequence later. This code is just to give you the length. This algorithm does not construct the actual longest increasing subsequence. Instead, it cleverly tracks the possible ends of increasing subsequence of each length. So I hope this explanation makes sense. And let's submit this code and let's see if all the test cases are being passed. So let's run in all the test cases. So hooray, all the test cases got passed. So this is the solution of this question in OF analog n. If you found this helpful, don't forget to like, subscribe, and drop a comment with your thoughts or questions. Keep coding, guys. I'll see you in the next video.